This is Swati, and in today's video, we'll see some very important questions on triangles of grade 9th. So, in my previous video, I've already explained all the concepts on triangles. Go check it out, and now let's get started. So, this video is divided into three parts A, B, C sections where we'll see 1, 2, 3, 4, and 5 marker questions. So, let's get started. First one, which of the following is not a criteria for congruence? So SAS is a congruence criteria. ASA is also. SSA is not a criteria. Next, in triangle ABC, AB is equal to AC. So here we have a triangle ABC where two sides are equal, AB equal to AC, and angle B is equal to 50 degrees. We need to find angle A. So the isosceles theorem states that if two sides are equal, their opposite angles will also be equal. So from this, angle B and angle C will be equal to each other. So if B is 50, C is also 50. So using angle sum property, you get A as 80 degrees. Now, next one. In the following figure, triangle ABC and triangle PQR are congruent using which of the following criteria? So, it is given that they are congruent. So, which criteria satisfies this? So, now here we can see that it is given both are 90 degrees, this equal to this and this equal to this. It is given. So, now which criteria is this? Now here, not every right angle triangle follows RHS criteria. No. So for RHS criteria, your hypotenuse should also be equal. But here I see that my hypotenuse are not equal. So it is not RHS. So don't get confused. Don't blindly write that, okay, it's a right angle triangle, so I'll mark RHS. That is not right always. So here we have two sides and the angle included. The angle is between the two sides. So it should be SAS. Now next, in triangle ABC, if angle A is 70, angle B is 50 and angle C is 60, and in triangle DEF you're given angles and AB equal to DE, which criteria helps you to prove congruence? So first let us draw the two triangles. This is triangle ABC. So here it is given A is 70, B is 50 and C is 60. And in the other triangle DEF, it is given angle D is 70, E is 50 and F is 60. And AB is equal to DE as well. So here I can see that angle A is equal to angle D, B is equal to angle E, and AB equal to DE. AB and DE is the included side. It is the side between the two angles. So it should be ASA, two angles and an included side. Next one. In triangle ABC, AB is equal to 8 centimeter, BC is 6 and AC is 10. And in PQR, PQ is 10 centimeter, PR is 8 centimeter and RQ is 6 centimeter. Which of the following is the correct representation? Now here this is very important. See, generally what happens is you need to also write the triangles properly. You cannot blindly write ABC and QRP. No. So I'll give you a technique how to write. So here I can see that side AB is equal to side RP, right? So how do we write? So first triangle can be written anyhow, ABC. Let us write the first triangle anyway, whatever you feel like. Now the next triangle, you should write corresponding angles. Now if I see that AB and RP is equal, then their opposite angles will be equal to each other. So opposite to angle A is C, and opposite to RP is angle Q. So C and Q are corresponding to each other. Similarly, side BC is equal to side RQ. Now, their corresponding angles will be equal. So, angle opposite to side BC is angle A and angle opposite to side RQ is angle P. So now the last one we can also directly write angle B will be corresponding to angle R. So this is how you know the corresponding. Now using this we can write the triangle. So it should be A is corresponding to P, B is corresponding to R and C is corresponding to Q. So it should be PRQ. Now which congruence we can see that all the sides are equal? So it is very clear, it is SSS. I hope this is clear. So this is the way to write the two triangles congruent. Alright, now next one, section B. Here you have 2 or 3 markers. In the given figure, BA is perpendicular to AC, DE is perpendicular to DF. So this is 90. Such that BA is equal to DE and BF is equal to EC. Show that the two triangles are congruent. So always in geometry, you will first write what is given. It is given BA is equal to DE and BF is equal to EC. And you also have B perpendicular to AC, DE perpendicular to DF. Now, we need to write what we need to prove. What do we need to prove? Triangle ABC is congruent to triangle DEF. Now, let's start with the proof. So here, you know, to prove two triangles congruent, you need 3 parts to be equal, right? So let us first write in triangle ABC and triangle DEF. So we have 90 degrees. Angle A equal, first one is angle A equal to angle D, that is given 90 degrees. Now second part is AB is equal to DE. This is also given to us. Now what is the third one? BF. But does BF lie in a triangle ABC? No. And also EC does not lie in a triangle DEF. So this part is missing for both. So since we are given BF is equal to EC, you know adding equal quantities doesn't harm. So can I add FC on both the sides? I can add FC on both the sides because we are short of FC. So BF plus FC will give us BC and FC plus EC will give us EF. Right? So from this we proved BC is equal to EF. So whenever you're short of something, be it a side or an angle, you can add that common side or common angle to both the sides. Now the third one is BC is equal to EF, proved from 1. Right? So now you always mark what you have proved. So 90, this and this. So what kind of what criteria are we using here? So therefore triangle ABC is congruent to triangle DEF by, this is right angle, this is AB is a side and BC is the hypotenuse. Hypotenuse is the side opposite to 90 degrees. So this is by RHS criteria. This carries 1 mark, the criteria. So you should mention the criteria. I hope this concept is clear because this will be used in further questions also. Now next one. L and M are two parallel lines intersect by another pair of parallel lines P and Q. So here L is parallel to M and P is parallel to Q. It is given. Show that. So what is given to us? L parallel to M, P parallel to Q. And what do we need to prove? We need to prove triangle ABC is congruent to triangle CDA. So let's start. So here if we see AD is parallel to BC and AB is parallel to DC. So from this I can write that ABCD is a parallelogram. So what is a parallelogram? It is a quadrilateral in which both the pairs are parallel to each other. So if it is a parallelogram, therefore all opposite sides are equal to each other. So AB and DC are equal and AD and BC are equal because opposite sides are equal in parallelogram. Now, let us consider the two triangles. So, triangle ABC and triangle CDA. First one is AB is equal to CD. Second is AD is equal to BC. And third is AC is common side to both. AC is equal to CA, common side, right? And hit for these two we have proved it. So you need to mention reason for every part. So therefore triangle ABC is congruent to triangle CDA by SSS. This is very easy. All the three sides are equal to each other. Now next one. In the given figure, AC is equal to AE. So AC is equal to AE. AB is equal to AD. And angle BAD is equal to EAC. So let us first write what is given to us. AC is equal to AE. AB is equal to AD. And angle BAD is equal to EAC. And what do we need to prove? We need to prove BC is equal to DE. So always you should mention given, prove, and then you will start with proof. So when you read the question, you simultaneously mark in the figure, so it will be easier for you. So now here it is given angle BAD is equal to angle EAC, right? Now we need to, so BC is equal to DE is what we need to prove. So for that first we need to consider what triangles. BC, so I take BC side, so the triangle that is forming with BC side is triangle ABC and the triangle that is forming with DE side is triangle ADE. So these two triangles we need to consider. So what all do we know? First one, we know AB is equal to AD. This is given. We also know AC is equal to AE. This is also given. Now, third one, mostly two things, two parts will always be given. Third one will be just you need to find out. Now, third one, we are given BAD. But BAD is not in our triangle. Our triangle is BAC. The angle is BAC. So, this part is missing. This part is missing here. Similarly, I have EAC equal. But my triangle consists of EAD angle. So, again, this part is missing. So as we did in the previous question, we can add equal quantities on both the sides. So here can I add that missing angle which is DAC? So I will add DAC on both the sides. So on adding, what do I get? BAD plus DAC will give me angle BAC. And EAC plus CAD will give me angle EAD. EAD. So this is the third part that is equal. So angle BAC is equal to angle EAD from 1. Okay. So therefore triangle ABC is congruent to triangle ADE by which criteria? So if I mention in the figure, so let me take this angle, right? I'll take this triangle, this angle, this side and this side of one triangle. So here we can see the angle is between the two sides, isn't it? This angle is lying between the two sides. So it should be SAS. SAS angle is included. So by SAS, both the triangles are congruent. I hope this is clear. It's a very important question. Next, again a very important. A triangle ABC is an isosceles triangle in which AB equal to AC. Side BA is produced to D, we can see, such that AD and AB are equal. So that BCD is right angle. So what is given to us? It is given that AB is equal to AC is equal to AD. And we need to prove that angle BCD is equal to 90 degrees. All right. So since AB and AC are equal, angle 1 will be equal to angle 2 because AB and AC are equal. As we have learned the theorem that if the two angles are if the two sides are equal, their opposite angles will be equal. Similarly, angle 3 and angle 4 will be equal because AC is equal to AD. Again, if the two sides are equal, their opposite angles are equal. You should mention the reason. Now, we will use this later. Now, we need to prove BCD is 90. So, let us consider triangle BCD. Angle 1 plus 2 plus 3 plus 4 is equal to 180 degree. Angle sum property. You need to mention the reasons in the bracket. I am not doing it because I do not have much space there. So, but you should mention. Now, you know 1 and 2 are equal. So, can I write 1 as angle 2? So this I can write it as 2 angle 2. Similarly, 3 and 4 are equal. So this I can write it as angle 2 angle 3 is equal to 180. So from this 2 can be taken out common. 2 plus 3 is 180. Or you get 2 plus 3 is 180 by 2. That is 90 degree. What is 2 plus 3? It is angle BCD. Hence proved. It was very easy. So whenever you see that it's an isosceles triangle, you will definitely use the theorem. If sides are equal, their opposite angles are equal, or if angles are equal, their opposite sides will be equal. Now next, moving on to the next question. Triangle ABC and DBC are two isosceles triangle on the same base BC. So ABC and ABC is isosceles, so AB equal to AC, and DBC is isosceles, so DB equal to DC. Now, vertices are on the same side. If AD is extended to intersect BC at P, show that triangle ABD is congruent to ACD. So, I will write in triangle ABD and ACD. Okay. So, here ABD and ACD. This triangle and this triangle. So what all are we given? We are given AB is equal to AC. We are also given BD is equal to DC. And third one, here if we see that this AD is common to both. So AD is equal to DA, common side. Right? So this is given because it's an isosceles triangle. So therefore, triangle ABD is congruent to triangle ACD by what? All the sides are equal by SSS. So now let me number it 1, 2, 3, 4, and let us take 5, 6. Okay, I'll just erase this. So since the two triangles are equal, therefore angle 1 and angle 2 are equal by CPCT. What is CPCT? If the two triangles are equal, all the corresponding parts are equal. Now next bit here we have, okay, ABP, ACP. So let us consider in triangle ABP and triangle ACP. So what do we have? ABP, the whole ACP. So again here we have AB is equal to AC. First one, it is given. And then we just proved 1 equal to 2, right, from the first part. And we can see that AP is the common side. AP equal to AP, common side, right? So therefore, triangle ABP is congruent to triangle ACP. By what? Now here we see angle, side, angle and side. So this angle is between the two sides. So this is an included angle. So it is by SAS criteria. I hope this is clear. Now the third one is, third question, AP bisects angle A as well as angle D. So what do we need to prove? AP bisects angle A as well as angle D. That means side AP is dividing the angle A and angle D in two equal parts. So we need to prove 1 equal to 2 and 3 equal to 4. Now, so for this, what triangle we will consider is very important, which consists of both. So 1 equal to 2 we have already proved from 1, right? So AP bisects angle A we have proved. Now 3 and 4 are present in which triangles? BDP and CDP. So this is how you will identify when you have multiple triangles. When you have multiple triangles, you will see what you need to prove and the proving part in which triangle does it fall. Those triangles need to be considered. So here you will consider in triangle BDP and triangle CDP. So let us write what is given to us. We know BD is equal to CD. This is given to us. We also know that DP is common. DP is equal to DP common side, right? And the third one is BP is equal to PC. BP is equal to PC. Why is it? Because it is given that if the side is AD is extended to intersect BC at P, so it is intersecting in two equal parts. So it is given to us. Given. So here I see that all the three sides are equal. Therefore, triangle BDP is congruent to triangle CDP by SSS criteria. And I can write angle 3 is equal to angle 4. And even I can mention 5 is equal to angle 6 by CPCT. This is 6, sorry, this is 6. Okay, so we have proved 3, 4 equal, 5, 6 equal by CPCT. Now last bit, what do we have in fourth bit? AP is perpendicular bisector of BC. Now here you need to prove perpendicular bisector of BC. So since we know that BP is equal to PC, we know, and also 5 and 6 are equal, we have proved, isn't it? We have proved 5 and 6 are equal in the previous question. So 5 plus 6 is equal to 180 because they are forming linear pair. So both are equal to each other. So I can write 2 angle 5 is equal to 180. Angle 5 is 90 degrees. 90 degrees means it is definitely perpendicular. Therefore, DP is perpendicular because it is 90. Also bisector. Perpendicular bisector of BC because BP and PC are also equal to each other. I hope this is clear. So when you have multiple triangles, see what you need to prove accordingly. Find your triangle. Now, this next question is your homework. Please do this question. This is a very important question again. So all the questions that we have done are very, very important. Go through the questions, and if you have any doubt in the concept, check my previous video. So see you in the next video. If you haven't subscribed it, please hit the bell icon so that you do not miss any important update. Thank you.